Hello everyone, today we'll take a deep dive into my favorite element in the periodic table, copper. Now, you might think, copper? Huh? That's weird. Isn't that the most useless ore in Minecraft? Well, you're not wrong, it is certainly useless. But in real life, it's a complete opposite. It's pretty much everywhere in our lives. I wanted to copper justice by telling you how essential it is for humans since the dawn of time, literally. The dawn of time from small things like, I don't know, being the first metal humans used, or a very, very small thing called, I don't know, electricity? Okay. First, let us talk about the atomic structure. This will be very quick as to not be super boring. Firstly, atoms. They're the building blocks of matter. Everything is comprised of atoms. Secondly, now, the subatomic particles. The protons are positively charged and found in the center, or what is called the nucleus of the protons. Now, let us continue. Then the neutrons have no charge. And now you can probably see the running theme going on. Positive protons, neutrons, neutral. Now let us continue. And lastly, electrons. Negatively charged, this one is moving around the protons and the neutrons. Then the nucleus, which I said earlier, is the center of the atom. A neutral atom has the same amount of protons and electrons. And now isotopes. Have the same amount of protons but a different amount of neutrons. They're nearly identical to their element but have different physical properties such as their stability or lifespan. And lastly, electron configuration. Well, you see, God likes to keep things tidy, so the rings of the atoms have a fixed amount of electrons that can fit 2, 8, 32, 50, 72, 98, blah 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 on each layer of the shell. The formula goes like this. Maximum electrons is equal to 2n raised to 2. N being the layer it's on. Example, 2 times the layer of the shell raised to 2 equals 2. And now 2x 2 raised to 2 is 8. How you write it goes like this. For example, Na or sodium, it has 11 electrons. So how you write it is like this. First shell equals 2 electrons. Second shell, 8 electrons. Third shell, 1 electron. Now remember, an element or atom whose outer shell is not full means it is unstable or it wants to react with other elements, whereas stable elements whose outermost shell is full don't want to interact with other elements. Or more simply, think of atoms as a boat, electrons being the passengers, and each row has a set of seats, and the first row having 2 seats for the pilot and co-pilot, the second row having 8 seats for the staff, the third having 18 seats. You see, electrons are eager customers who want a seat at the boat, and if the passenger seats are full, the electrons can't sit down on the boat. This is also the reason why copper is such a good conductor of electricity. Since copper only has one electron in its outer shell, it can move freely from one copper atom to another, so when a voltage is applied, this lone electron easily flows through copper, allowing electricity to flow efficiently. And now finally, let's talk about the atomic structure of atom. Copper has an atomic mass of 29, and in the coinage metals, it has 29 protons and 35 neutrons. Its atomic mass is 64. You always want to have an even number for the atomic mass. Its configuration is 2, 8, 18, and 1. So to draw it, or make a model, you first need to draw a big ball in the middle, and then draw 4 rings around the circle. And then on the first circle, you draw 2 small balls, one on the top, one on the bottom. Then on the second circle, 4 on the top, 4 on the bottom. Remember to evenly space them out. And then the next circle, draw 18 small balls. Do the same as the last circle. And now finally the last circle. You only have to put one ball in there. So you put it wherever you want it to be. Okay. Let's stop talking about balls now. I'm so sick and tired of balls. And now, lastly, let us talk about the physical and chemical properties of copper. Copper has a reddish brown color and a metallic luster. It weighs about 8.96 grams per centimeters raised to 3, making it quite heavy. Its melting point is 1085 degrees Celsius and its boiling point, and yes, metal can boil, and it is very, very hot, 2562 degrees hot. It's very malleable and ductile, and it's very resistant to corrosion due to its protection barrier, copper oxide. Copper is relatively soft compared to iron and steel. It's about 3.0 on the Mohs scale, a scale determining the hardness. Okay, now let's talk about its chemical properties. Copper isn't really reactive compared to other metals, but it does react to strong oxidizing agents. Oxidation is when an atom, primarily metal elements, lose electrons when it comes in contact with oxygen, or oxidization agents. For example, have you guys ever wondered why the Statue of Liberty is green? Hint, they didn't paint it. Since they used pure copper plating on the Statue of Liberty, with time, the pure copper plating began to change appearance. Because when a metal atom loses electrons, it becomes a positive ion. And in the case of copper, forming copper oxide. And finally, copper easily forms alloys with other metals such as brass and bronze. Brass being copper plus zinc, bronze being copper plus tin. And now that we're finally done with all that, let us now talk about the history of copper. First things first, let us talk about where it's found. Copper is often found chilling with other elements such as lead, zinc, gold, and silver in deposits. However, larger amounts of copper are found in porphyry copper deposits. That was once larger masses of molten rock that cooled and solidified in the Earth's crust, making copper. Alright now, finally, let us dive into the history of copper and why it's the best metal of all metals and why it's the most important metal there is. During the Stone Age, 10,000 BC, copper was the first metal that humans manipulated, which made humans turn from the Stone Age into the Bronze Age. Well, I like to call it the Copper Age, marking it a shift where humans started using metals. Now, let's do a bit of fast forwarding, and now we're in 5000 BC. Humans begin molding copper into tools and weaponry, which is way more durable than most rocks, but copper is soft, which made it a double-edged sword. Sure, it's easily shaped and modeled into whatever you want it to be, but it's less durable. During the ancient era, Egyptians and Mesopotamians, especially the Egyptians, used copper extensively. Copper played an important role in their culture. They used copper for building the pyramids, and its softness made for easy tools. And it was even used to treat infections, as copper has antimicrobial properties that kill or stop their growth. In Mesopotamia, copper was used for coins and as a valuable trade item. Okay, now let's move to the Roman Empire. Also in 5000 BC, maybe the coolest empire ever, the Romans mined large amounts of copper and refined it. They're kinda smart, no? Making one of the earliest uses of plumbing systems. Also, a fun fact, the symbol of copper is in the periodic table of elements. Was taken from the word cuprum, a Latin word originating from Cyprus, where the Romans first discovered copper. Now, let's move to the Middle Ages, 500 to 1500 AD. By the way, AD means Anno Domini, meaning after the year of Christ. Now, during this period, advancements in copper mining in Europe made the process way more efficient, leading to an increase in production. And then copper was then alloyed with zinc to produce brass, which was widely used in weaponry, armory, and instruments. Now onto the Industrial Revolution, a time marked for the rise of child labor and pollution. I mean the transition to the rise of factories and monopolization. I mean the mechanization, deforestation, urbanization. Technological advancements such as the moving carbon emission 9000, the steam engine, which paved the way for faster public transport. Copper played a huge role in this due to its affordability and malleability, which means metal can be easily bent or shaped, making copper ideal for machinery, being essential for the pipes, tubing, and factories, allowing the Industrial Revolution to thrive. Now, let us move away from those very, very dark times. Oh, wait a minute, is that a light bulb I see? Oh, it is! The year is 1879. During this period, Thomas Edison invented the world's first electric light bulb, which made these years less dark and brighter. Well, physically at least. Ethically, well, that's a different story and a different subject to tell. If we're talking about electricity, we can't really forget about the man who invented the 20th century, a man ridiculed in the past and glorified in the present and the future. A man who created a technology that makes billions, even trillions in value, however died not being able to afford even a proper burial. None other than a legendary inventor, Nikola Tesla, who used copper due to its amazing electrical conductivity and how it can easily be shaped into wires and thin strands, essential for electrical components, which was crucial for Thomas Edison's electric light bulb and essential in Nikola Tesla's alternate current AC systems, making long-distance electricity transmission possible. Now, to the present day, copper remains a crucial element for the construction of technology. The modern day wouldn't be where it is without copper. And now, the conclusion is, copper was the first metal humans used, and is still being widely used today, making it, in my opinion, one of the most, if not the most important metal for humans. It contributed from weaponry to armory to even instruments, and most importantly, technology. So ask you this, can you imagine a world without copper?